Lesson 15.10 is writing an equation of a perpendicular bisector. So number 1 says find an equation for the perpendicular bisector of the line segment whose endpoints are at 9, 7, and 5, -7. So let's back up and first talk about a perpendicular bisector. Those two words mean both very specific things, perpendicular and bisector. So bisector means that it's bisecting another line. It's cutting a segment into two equal parts. So we're going to have to find a midpoint of that segment, first of all, so that we know where the middle of it is to cut it into two equal parts. And then we're also going to have to do something with slope because they're going to make perpendicular lines, which means they intersect to form right angles. And so we'll have to have those negative reciprocal slopes. And I will tell you on Delta Math, you're not going to have a graph. They're going to just give you the words. And so you have to be able to work through it in your head or get a whiteboard, and on the back side has the coordinate plane to help you. But you've got to be able to do the algebra with it. So to get started, let's plot the point, so at least that gives us something to go off of. So there's one point at 9, 7, which would be right here. There's another point at 5, -7, which would be right here. So this becomes our line that we're trying to form a perpendicular bisector of. That means the other line's going to go through something like this, to where it's going to make these perfect right angles and it's going to cut through the middle of this line. So number 1, to find the midpoint, remember that we're just averaging the values. And so that is taking my points here that I already have, and to find the x values, I'm going to just average them. So I'm going to have 9 plus 5. Remember, averaging is dividing by the number of numbers, and there's always two numbers in these. So 9 plus 5 divided by 2 will get me the x value of the midpoint. And then I'm going to have 7 plus -7, or 7 minus 7 divided by 2 as well. That puts my midpoint at 9 plus 5 is 14 divided by 2 is 7. 7 plus -7 is 0. 0 divided by anything is 0. So my line looks pretty good because there is the midpoint. Okay, step number 2, let's figure out the slope of our existing line. So of course on this graph you could just count rise to run, rise to run. But if you're doing it mathematically, remember slope formula is m equals y2 minus y1 over x2 minus x1. So that would be -7 minus 7 over 5 minus 9. That would be -14 over -4. Negative divided by negative is going to be positive, and then I can divide each number by a 2. That would be 7/2 is my slope. Or I could count, like I said, up 7, right 2 is the slope. But to be perpendicular to that, I have to make it be the negative reciprocal. So I'm going to flip and have that be -2/7. So now I have everything that I need to be able to write a line to be a perpendicular bisector. So let me switch colors real quick. You have the two options. You can either do point slope form, which is the y minus y1 equals m times x minus x1. This is how I always used to do it, so I'm more comfortable with that. It's just what I go to first, or just use y equals mx plus b, and then you'll have to actually solve. But I think I'm going to use this one. So I'm going to go y minus, I'm using the midpoint y value. So y minus 0 equals m. I'm using the slope here, -2/7 times x minus my x value from my midpoint. So point slope form is always used when you have a specific point you want your line going through and you have a specific slope you need it to have. And so really this -0 does nothing, so I can kind of just ignore that. And I'm sure Delta Math probably would just take it like it is right now, but I'm going to distribute. So I get -2/7 times x. Negative times negative is a positive, and then the 7s are going to cross simplify, so that would leave me with the 2 in the numerator. So my equation of my perpendicular bisector would be y equals -2/7 x plus 2. If I were to graph that to check, that means my y-intercept is +2, and my slope is going down to right 7. So look, I'm going to hit this point that I needed to, and it's going to make a perfect line that cuts the blue line in half, and they're going to make these perfect right angles where they cross.